Let's have a look at the trend for ionization energy. Ionization energy is the amount of energy required to remove an electron from an atom. Basically, it tells you what is the tendency for that element to form a cation. Pause the video and copy down the same Bohr diagrams from the other page. We'll use them again to compare structures of atoms. The stronger the effective nuclear charge of the atom, the harder it's going to be to pull an electron off, and the higher the ionization energy value will be. Removing one electron off of an atom is known as its first ionization energy. If you then try to remove a second electron, that's known as the second ionization energy. First ionization energy increases as you move across a period. This again is because of proton attraction. If we're comparing the ionization energy between lithium and beryllium, remember that these two elements both have two shells of electrons, so they have the same electron repulsion. So what sets up the difference in effective nuclear charge is how many protons are pulling on that valence shell. Because beryllium has one extra proton holding the valence electrons on, it will be harder to pull an electron off. Therefore, beryllium has a higher ionization energy than lithium does. Going down in the periodic table, the first ionization energy decreases. This is because of electron repulsion differences. Looking at lithium, its valence electron, which we're trying to remove, is being repulsed only by one shell, whereas on sodium, the valence electron we're trying to remove is repulsed by two. This means sodium's valence electron is less firmly attached. It has less effective nuclear charge, so it will come off easier, and sodium will have a lower ionization than lithium does. Also on your class periodic table are some arrows for trends in the bottom left corner. IE, or ionization energy, increases as you go up the table and to the right. Pause the video now and use your periodic table to try some ionization energy questions. In the first set, because nitrogen is higher in the periodic table than phosphorus, it will have a higher ionization energy. In the second set, because magnesium is further to the right, it beats out sodium. And in the last set, argon is both higher and further right than calcium. The patterns for second and third ionization are a little bit different than first. Pause the video and copy down the Bohr diagrams for sodium and magnesium. Looking at the structures of these two atoms, we can figure out which one has the highest second ionization. Let's start by pulling two electrons off of magnesium. The first electron I pull off is relatively easy because I've got three shells of electrons, so lots of electron repulsion. If I go and pull off that second electron, it becomes a little bit harder, because when the magnesium loses the electron, it then becomes an Mg with a 1 plus charge on it. And I'm trying to take something away negative from something that's positive, it gets a little bit harder. Let's compare that to sodium's. The first electron I take off comes out of that third valence shell, the same as magnesium's. It's going to be easy. But if I go to take a second electron, I have to take it from sodium's second shell, which is closer to the nucleus. This is going to be a lot harder. Because I've lost a valence shell, I have less electron repulsion, and the sodium now has a greater effective nuclear charge. So it's going to be really hard to take off that second electron. When you're pulling multiple electrons off of an atom, each successive electron gets a little bit harder, and you always experience a huge jump whenever you switch shells. This is due to the electron repulsion difference. Draw some Bohr diagrams of calcium and scandium and figure out which one has the highest third ionization energy. The answer is calcium. It will have a higher third ionization energy because when you go to take that third electron off, you have to jump to a closer shell. The third trend we're going to cover in grade 11 is electron affinity, or EA. It's the opposite of ionization energy. It's defined as the amount of energy released or absorbed when an atom gains an electron. And the higher the electron affinity, then the more likely that element is going to become an anion. The pattern is the same for ionization energy. Electron affinity increases as you move across the period, moving from the left to the right on the periodic table. This is because as you move to the right, there are more protons in the nucleus pulling on the same number of shells, so you have more proton attraction. Electron affinity also decreases as you move vertically down a group. This is because atoms further down in the table have more electron repulsion, so any electrons you're trying to add on to the atom won't stick as well. Try out some electron affinity questions. In the first set, because fluorine is higher in the table, it will have a higher EA. In the second set, because oxygen is further right in the table, it will have a higher EA. And nitrogen is both higher and further to the right than sodium is, so it wins. The fourth trend is the one that we'll use in this course the most. It's electronegativity, represented by En. It measures an atom's ability to attract a pair of electrons that are between two atoms being shared in a bond. Now the bond could either be an ionic or covalent. Electronegativity follows the same trend as ionization energy and electron affinity. As you move across a group in the periodic table, there's more proton attraction, so the nucleus can pull on that pair of electrons harder. As you go down a group in the periodic table, there's more electron shells between the pair of electrons in the bond and the nucleus, so they experience more electron repulsion and the atom can't pull as hard. Using your periodic table, determine which elements have the highest electronegativity. Because chlorine is further right, it beats out phosphorus. Beryllium is higher than barium, and silicon is both higher and to the right. Tomorrow we'll discuss how we can use electronegativity to figure out what kind of bond is between two atoms. Is it ionic or is it covalent?